Okay, hi class. This is the next lecture covering numerics and string data. If you're following along, the last part of chapter 3, like the last part of the PowerPoint, starts to cover being able to debug in Visual Studio. And I did skip over it, and it's not because it's not important. It's actually one of the most important things you can get out of this course. But instead of covering it explicitly in a chapter, what I like to do is just incorporate it in my lectures. Every time we do something, or every time we test out a feature or a bit of functionality that we've added to our application. So rather than go over it and take the 15 or 20 minutes to go over that in detail, what I like to do is just go over it as I teach and as I lecture. I like to build it into pretty much everything I do because that's how important it is. It should be something you shouldn't do once and then throw away. It should be something you do with every single program you create, every single feature you create. If you don't understand something, you should be using this and stepping through it. So that being said, be on the lookout for that whenever I run my program and I run into a problem, or I try to explain something more in depth. What I'll do is I'll actually set breakpoints and actually step through the code and watch the compiler go through it. So that'll make more sense, and I'll try to call it out when I do it. That way you can see how it works and what I'm doing. So that being said, Chapter 4 covers working with numerics and string data. We've already done it a little bit throughout the lectures. We've done working with decimals. You should have already, in Java, worked with a lot of different numerics and data types as well. It isn't really different at all. In C#, there's a couple extra ones that we'll talk about. But the only thing that really changed is the name of some of them, maybe. But that's about it. So if you're following along in the PowerPoint for Chapter 4, again, sorry I don't like showing PowerPoints just because I don't like giving you guys death by PowerPoint. The 5th slide covers built-in value types. So again, they're the exact same things that you'll see in Java. So if I go to, since my submit button actually does something, let me put another button on my form. That's just going to be used to go over some built-in value types, and I can just remove it or whatever else. So I'm going to add a button. You don't have to go through this if you don't want. If you just want to follow along with my lecture, I'm just going to end up deleting the button and the event tied to it later. btn test. I'll go ahead and double click it. That way it gives me an event handler and registers my event handler for me. Okay, now that my event handler is made, I did promise last lecture that I would make this full screen. So actually a shortcut you can use in Visual Studio is Shift plus Alt plus Enter if you're in the code window. And notice that it made my code window full screen now. So if it's, hopefully it's a little bit easier to read without all the clutter of everything else around. Okay, so that being said, we do have a lot of built-in value types in C#. It should be, by and large, review of Java or review of programming in general. The ones we'll mainly use are int. So notice when I start typing, the IDE will try to give me some hints of what I want, so I can use int. I can give it a name. I can just use I or whatever equals 5. I'm just going to use I because the name really isn't important. I'm not going to use it for anything, but this should be a meaningful name if you are using it for something, but I'm really not going to be using it for anything, so I'm just going to say int I equals 5. And notice if I hover over it, it represents a 32-bit signed integer. So what does that mean? That means 32 bits, that's how many bits that it takes up in memory. And signed, which means that it goes positive and negative. So I could also, in contrast, I could use like a uint. And that is an unsigned integer, so that only goes positive. So not a lot of, like, memory is cheap anymore, so not a lot of people put a lot of thought or effort into what variable types they're going to use. It was more of a big deal whenever you were doing when maybe COBOL or older programming languages, or memory is more expensive, or hardware didn't have as much memory on it. But nowadays, whenever you see me code, I'll probably just be using things like integers. You'll seldom ever see me use like a uint or anything like that. There's also shorts. Signed and never used. Oh, there we go. A 16-bit signed integer, so that's just a smaller integer. So again, memory is cheap. Usually people don't use shorts for any reason. Usually it's just integer. Just like the integer, you can use a ushort. So it takes up the same amount of space, but it'll go higher in number. So for example, an integer, 32-bit, which means an integer can go up to around 2.1 billion. So if your number is above 2.1 billion, you want to use something higher than an integer. So for example, a long. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see that's a 64-bit signed integer, so that goes up to a higher number. Notice if I try to assign my int something like that, it'll give me an error message that it cannot convert a long to an integer. So it notices that it cannot put this thing into such a small data type. But my long says, okay, yep, I can handle that number, that's fine. So that's the main difference between these three data types. An integer is the medium, more used one. You can also have a uint. So notice that this is unsigned now, so this only goes positive. So now this, if you multiply this by 2, it'll go up to about 4.2 billion because it doesn't have to worry about those negatives anymore. So that'll go up to 4.2 billion. Same thing with the ushort. This can go up to 32,000 since it's 16 bits. So if you just take 2 to the 16 is how high this will go. And then again, 2 to the 64 is how high a long will go. So we're working with integers. If you want to work with anything like decimals, you can use a float, or again, more often, the thing people will use is a double. We used a double when we were trying to figure out a discount percent, or maybe that was did I use a decimal when I tried to figure out? That might have been a decimal. Yeah, that's a decimal. So a double uses this D to signify that it's a double. And then if we hover over double, it'll tell us that it's a floating point number or precision, which means you can have a decimal in it. And it goes out to 14 significant digits. So again, to contrast that, if we want something bigger than a double, we've already seen we can use a decimal. It's 16 bytes and up to 28 significant digits, so this is just double the size of a double. And we use an M to signify that it's a decimal. What is not like about this? Oh, I don't have a name. Okay, so we talked about an integer, and we can have these signed or unsigned. Long, if we want to have a bigger number, we're working with maybe bytes of data. And if we're working with decimals, we can use doubles or decimals. There's also booleans, which we have used when we are working with like a checkbox, whether or not it's checked, is that true or false? And again, boolean is just true or false, yes or no, 0 or 1. If statements take into boolean, so it wants to know whether or not something true or false. When we start covering loops, a while loop, we'll look at a boolean. So it'll do something while something is true. When something becomes false, it'll make it false. Another important character or value type is a char. And those are 2 bytes, and it's a single Unicode character. So we can say char C equals something like that. So anything more than 1, you're gonna get an error because now it's a string. But just 1 is a character or a char. So this will become important. It's not used a lot like this, maybe but for console programs, but it is important when we start talking about strings because of what type a string is or how a string is developed in memory. It deals with characters or underlying characters, and we'll talk about more of that later on. So these are all considered value types. So I left out, we also have uint, ushort, ulong. We talked about char, boolean, decimal, double. There's also a float, which is just a little bit smaller than a double. Again, not used very often just because of how cheap memory is. And there's also byte, which is just 1 byte of data, 8 bits. 8 bits is a byte, so it goes up to 256 or 255. There's also sbyte, which is a signed byte. So that's signed. So that'll go from negative 128 to positive 127. So again, this has to deal with the sign, a negative sign. This doesn't, so this will go up to 256 or 8 bits. All right, so we're talking about bytes, sbyte. I can probably move this value type because a byte is still a value type. There's an int, there's a short, there's a long. So these are all integer types. You can't have a decimal with them. Here are the types that you can use decimals with: floats, doubles, decimals. And then here are the ones that are kind of one-offs: your bool, which is your true or false, and your char, which is just your single Unicode character. So the next part of the chapter covers how to initialize these variables. So again, here's how you initialize any of these variables. You can initialize them in 1 statement or 2. So I can also have int I. Notice that there's nothing with that at the moment. It's assigned but never used. I equals 5. Oh, this is already defined. That's why I'm getting an error there. So here's my integer, and then here's where I actually define it down here. So if you want, you can initialize it and define it in 2 different areas. It's okay. But until you actually give it a value, it'll just be 0. So for example, let's use one of my labels. I don't think I gave any of my labels a name. Let's change the text property to whatever is in this integer. The text is a property, it's not a method. .text equals integer dot toString. So I'm going to convert the integer to a string and try to put in this text property. But if we look here, use of unassigned local variable, what does it not like about that? Let's try to assign it and see if it likes it then. Yep. So see, I never gave it a value, so it's going to give me a compile error. So without a value, it's like, hey, I don't know what this thing is. I know it's an integer, but you never actually gave it a value. So I can't really call a method on it because it doesn't have a value. It's going to break. So your code isn't even going to compile here. So let's go ahead and get rid of this and go back to where we started. Okay, for the last part of this video, I'd just like to cover the arithmetic operations. Again, it's nothing that we haven't done in Java, so it should be, for the most part, review. So if we have 3,000 here as an integer, let's make another integer ij 3,000, 4,000 maybe. And then let's make a method that adds these two together. So let's say, let's change a label for my label 1. Is that a lowercase l? And the text property for that label is going to be set equal to add I and j. So I want to add I and j together and set it equal to this text property. There's currently no add method on my form. So I'm going to show potential fixes, and I want it to generate a method invoice.add. And then it gives me a little help here and generates my method for me. And it already knows that it takes two integers because that's what I put here. So all I really need to do is implement what I want my method to do. And all I want it to do is return I plus j. And it returns a string. So let's go ahead, I plus j dot toString. So now when I click the button, I should have I and j. I'm going to send it and have it add them two together and then put it on this text property. It knows it's a string because it's setting it equal to this text property that's a string. So let's go back to the small window again, hit start. And now my label 1 text property should be 7,000 when I hit this test. I think the subtotal is probably my label 1. So test, and now it's equal to 7,000. So going back, just to recap what we did there, I sent it to an add method, and I performed the add operation with that. So there's also a subtract operation with integers. I'll just leave the method the same name, but I can also subtract these two integers. With the minus operation, I can multiply these two integers. With the ampersand, I can divide with a forward slash. Or I can use the modulus operator, which actually returns the remainder. So here's the modulus operator. So if I is 3,000, let's make I 4,000. And let's make this 3,000. So I, which is 4,000, divided by 3,000 should give you 1, with a remainder of 1000. So it should put 1000 in that label. Let's test, and there's 1000. So that's what the modulus operator does. If you've never used it before, it's useful if you want to tell if something has a remainder or if something is divisible by something else. So if you have the modulus operator and it equals 0, you know that something is divisible by that other number. If you want to check to see if something is even or odd, you can have it be divisible by 2, and if its modulus is 0, you know it's even. So that's what the modulus operator does. Let me make that back to add to make the method make sense again. And then you can also have increment and decrement operators, which we'll work with a little bit more when we start talking about for loops. So remember, you can do int a equals I++. So that's just adding 1 to whatever I is. So that should be 4001 now. Or you can also do I minus minus, which will subtract 1 from that, or it can be 3999 now. So those are the increment and decrement operators. So all it takes is just whatever I is and subtracts 1 from it. Whatever I is, add 1 to it. So that's the same as saying I plus 1. Okay, so those are all of the value types, and I'll cover a little bit more about what value types are in a later module. Don't worry too much about that right now. In the next video, I'll start to cover strings, and we'll start talking about reference types and how strings or why strings are reference types because of their relationship to the character value type. So see you in the next video.